Fantastic. Okay, so my name is Mike Hearn, and I'm a Bitcoin developer. I've done a lot of work on core developments, and I've been involved with Bitcoin since, well, I've used it since 2009, and I've been developing it since 2010. And today, I wasn't sure what to write about. Hands up if you think you're sort of technical-ish. I never quite know what to expect of these meetups, about half. Yeah, it's about what I expected. So I want to give you a bit of a look ahead, brief look ahead at stuff that's going on in the development world, upcoming features, and then I'll talk about some other stuff. Oh, this doesn't work. But is this slide the last slide or the first slide? That's the last slide. That's why it says thank you. I was like, that's a very polite. I don't remember being so polite. Up. Okay. Oh, no. There we go. Is it up or is it down? It's down. Okay. So I've worked a bit on the Satoshi client, but actually mostly I work on this library called Bitcoin J, which underlies the Android Bitcoin wallet app by Andreas Schildbach, and also Multibit, and an upcoming Mac wallet called Hive. And then there are a couple of other wallet apps that use it as well. And it's also used in blockchain.info and a bunch of other apps. Satoshi Dice used a bit of this code as well. A whole bunch of things. Hands up if you use the Android Bitcoin wallet app or Multibit. Okay, a pretty decent number. So these are what we call, these are sort of like lightweight peer-to-peer wallets, right? So when you use these apps, you're talking to the peer-to-peer network. And when you use something like blockchain.info or Electrum, you're not. That's kind of the key difference. So one of the things we're doing is we're working on these HD wallets. That's not high-resolution wallets. That's hierarchical deterministic wallets. One problem we've got at the moment is like wallets are not really compatible with each other. I mean, they all talk on the Bitcoin network, but if you have a wallet and you want to import it into another app, then maybe it works, maybe it doesn't. HD Wallets is a project to standardize wallet formats and allow you to just write down 12 words on a bit of paper, and then you can restore into any wallet app. So you see some of these things happening at the moment with paper wallets, and like Electrum has pioneered some of this stuff. What we're doing is we're standardizing it, making these techniques better so everything will use it. And this is really important for the Trezor hardware wallet, which is coming up. It's going to start shipping this month, actually. And then we need to get everyone onto these hardware wallets because otherwise you're all going to get your money stolen, basically. What else are we working on? So, Bitcoin addresses. I love them. They're nice and simple. We need to scrap them, right? Because they are too limited and they cause all kinds of problems. So starting at the end of 2012, myself and Gavin brainstormed a lot, and we did a lot of design work on something called the Payment Protocol, which is a really dumb name because don't we pay with Bitcoin protocol? Well, yeah, but we don't have a better name for it. The Payment Protocol basically replaces addresses with small files that contain payment instructions. And because these are little files, we can add data to them and add features over time. And this is going to be really important for lots and lots of features that we need to implement over the coming years. Version 1 of the Payment Protocol, which is just a start, when you pay with it, you can submit a refund address to the merchants so they can refund you reliably. Today, that sort of doesn't, people try and do refunds with Bitcoin. It doesn't really work. Memos, so you can get a message from the merchant and you can send a message back when you pay. Currently, you can't attach messages to Bitcoin transactions. That's going to be fixed. Receipt. If you buy something with Bitcoin today, you have no way to prove that you made a purchase. And this means if there's any kind of dispute, you just have to trust that it's going to work out okay. All the information in Payment Protocol can be signed under some kind of verified identity. If you want, it's optional. And so this means you can get proof of purchase, and this is useful for bootstrapping dispute-mediated transactions and all kinds of other things, and loads of stuff. So like dispute mediation, maybe in future social network integration, privacy upgrades as well, basically loads of good stuff. Fees. You've probably noticed that in the last 8 months, Bitcoin became about 80 times more expensive to use than it used to be. This is because there's a minimum fee requirement on transactions, which is hard-coded, and it's set in terms of Bitcoin. So when the value versus the dollar went up by 80-fold, so did the fee. This makes no sense, because it didn't actually become 80 times more expensive to process a transaction. So at the moment, Gavin is working on this pretty heavily, and I've been doing a bit of work on this as well. We're going to make the minimum fee float. So the idea here is that hopefully we can really start forcing fees down this year, and this is going to be important once we start making the scalability upgrades needed to go beyond 7 transactions a second, which, as Jeremy pointed out, is not much. Visa actually handles 10,000 transactions per second at peak, and that's just Visa. Right? MasterCard is another 9,000 transactions per second on top. Also, fees, currently the sender pays the fee, even though it's the receiver that cares about the confirmation. This makes no sense. We need the payment protocol to fix that as well, a bunch of other stuff. Something I've been looking at in the last few weeks, actually, is for these peer-to-peer wallet apps like the Shieldback Wallet and Multibit, can we route all traffic through Tor by default? Does everyone here know what Tor is? Yeah, everyone knows what Tor is, great. So this solves a couple of problems. One is it gets that traffic encrypted for most of the way towards the peer-to-peer network, which is pretty useful. This is not only useful for annoying people at GCHQ, but it's also useful for more mundane annoyance, like the people who are sharing your Wi-Fi hotspot. And right now, if you connect to, if you send payment, for example, with one of these peer-to-peer wallet apps, the data isn't encrypted at all. So anyone who can see your internet connection can see that. Routing everything through Tor by default is somewhat ambitious. It's possible because there's a library these days which allows you to integrate Tor into apps. But it's something that we should probably start thinking about, and I'm hopeful we can switch this on for everyone who uses wallets based on my code, at least probably in the next 2 to 3 months. There's a second reason why we need to do this, though, and that's that I'm very worried about something that never happens, luckily, today. I'm very worried about Wi-Fi hacking attacks. So one of the when you use a peer-to-peer wallet, right, you're connecting, by definition, you are connecting to computers on the internet that are run by people you don't know. They could be run by anyone. So this poses an interesting question, which is, how do you know you're connected to the real Bitcoin network and not a simulation? And this might seem a bit abstract, but it's really not. If all you care about is confirmed transactions, you can just download the blockchain. And even with these lightweight Android wallets where they don't really have many resources, the upgrades we did last year allow you to download the blockchain and verify a bunch of mathematical proofs, check it all hangs together, and that can't be forged unless you can do a majority mining attack. So that's good. But in practice, people often don't want to wait for confirmations. And there's a bunch of other things where you don't really have much other choice but to just connect to a bunch of random computers and ask them the same question and then sort of hope they agree, or average out their answers. So if you're connected to a simulated network, this is a problem. What does this look like in practice? Well, imagine that you meet someone or you arrange something on local Bitcoins. You've heard about Bitcoin in the news, and you want to buy some. So you go to a coffee shop, and you sit down. You're a bit early, or maybe they're a bit late. So you look at your phone, and they say, oh, great, free Wi-Fi. I'll use that. And then the trader comes along. Hi, how's it going? Great to meet you. He takes your stack of pound notes, and he scans your phone. And on your phone, you see, pending confirmation payment. Here's some Bitcoins. Great. You walk out, and hours later, you're wondering why it still hasn't confirmed. Well, the answer is that the hotspot you connected to isn't a real hotspot at all. It's actually a mobile phone that's, looks like a real hotspot, and your internet access worked, but you weren't really connected to Bitcoin at all. And the transaction you thought you saw didn't really exist. I think we're lucky this isn't happening at the moment, probably because of diversity in wallets, and some of them aren't decentralized. But using Tor is an authenticated peer-to-peer network. So by using Tor, we can solve this problem because you can't simulate the Tor network, basically. Unfortunately, what Tor gives us on one hand, it takes away with the other. So you can't fool your phone into connecting to a fake Tor network anymore, and that's good. But if you want wallets to connect all the way, be encrypted all the way using hidden services, now we've got a problem because Tor hides the IP address of the nodes you're connecting to. So how do you know that you're not victim to a different kind of Sybil attack? These attacks based on fake nodes are called Sybil attacks in the literature. How do you know that you haven't connected to what you think are 10 different nodes and they're actually all the same computer? Well, you don't, right? That's sort of what Tor is designed to avoid you finding out. So we've got a problem. Probably in the next couple of months when we throw the switch on this, you won't be connecting to hidden services. It'll just be through exit nodes, and your traffic won't be encrypted all the way to the peer-to-peer network, just like most of the way. But it'd be great to have a solution for this. So we've been thinking about this. This is Gavin, and I love this shot. He's burning some money. So what we need is a way to make simulations of the network expensive, prevent you from bringing up 10,000 fake nodes that are actually all on your computer. And a proof of sacrifice is this interesting technique where you take some Bitcoins and you spend them all to miners' fees. So you actually throw them away. But when you do this, what you leave behind is a proof in the blockchain that you took some coins and you sacrificed them, right? You effectively just threw them to the wind and they were picked up by some random miner. And because Bitcoin transactions have public keys in them, you can then prove that you were the one who did this. So if we make our wallets prefer Bitcoin nodes that have made some sacrifice of money, then you increase the cost of bringing up like 10,000 fake nodes. Suddenly it's not just a cost of a few internet connections, but you actually have to make 10,000 sacrifices, which could get expensive. And this is really easy to implement, so that's cool, but has an obvious problem, doesn't it? Yeah, I mean, we don't actually want to make Bitcoin expensive to run. We want to make it cheaper to run. Because the cheaper it is and easier it is to run, the more decentralized it is, right? We want lots of people to run Bitcoin nodes on the peer-to-peer networks. So this would solve one problem and just create a different one. So lately, what I've been looking at, actually for the last 6 months or so, but I haven't been able to try it yet, the code isn't open source, is something new. And this is a proof of a passport. Now, what we really want to avoid Sybil attacks is an object that everyone has, but no one has more than one of, and which you can prove you own over the internet, and is anonymous. Now, you may have noticed a slight flaw in my plan. Okay, passport. Everyone has one. Well, unless you go into Iowa and places like that where people never leave America, so they don't have passports. Most people who are going to run a Bitcoin node probably travel and have a passport. But no one really has more than one, or we hope people don't have more than one. Governments put a lot of effort into making sure that doesn't happen. Trying to manufacture 10,000 passports out of thin air, probably you're going to fail. Or at least, if you don't, then people are going to come after you. But how do I prove I own one over the internet? And yeah, it's not anonymous. So we're not really there. Well, so it turns out that passports have this interesting thing inside them. They've got this NFC chip, and it's just a regular NFC chip that speaks standard protocols, which means you can actually read it with an Android phone. And this is what it looks like. This is a neat party trick. You can just put your phone against the passport, and after you've scanned some code on the inside page, you can read it. So this is what mine looks like, of course. But by itself, this is kind of useless. But what's more interesting is that the data in it is actually digitally signed by governments. So this is a computer file, effectively, which is very hard to forge, yet almost everyone has. So we're getting a bit closer. Some kind of passports you can actually prove you own over the internet, because you can challenge the chip with a nonce and it will sign it with a private key. Unfortunately, as you can see, British passports don't, because the British government is too goddamn cheap to support this technology. No, I mean, seriously, a lot of governments don't bother with this feature. It's optional, and they probably feel like cloned passports are not really an issue. But, okay, so it seems like we got so close, but we failed, and we still don't have a solution. People don't want to upload their passport data to the internet, right? Especially not to just run a Bitcoin node. So it seems like we're almost there, but we've still failed. And then at the last Bitcoin conference in May, these bunch of very clever mathematicians stood up and they gave a very interesting talk. And it sort of blew everyone's minds, and we're still working through the implications of this 6 months later. And this talk, well, I can't even, so the technique they've invented allows you to produce proof that you ran a program correctly. And these proofs are called ZK snarks. That's short for zero knowledge, succinct, non-interactive argument of knowledge. And if you think the name is a pain in the ass, the maths is 10,000 times worse. This is a 45-page paper, and almost every paragraph cites a different paper without reading which you can't understand it. So I'm still working my way through the math 6 months later to try and understand how this works. But basically, what you can do, this allows us to solve our problem. Because what you can do is you can scan your passport, and then you can optionally select some fields from it to reveal, or no fields, if you want to have a completely anonymous passport. And the programs that this technique lets you prove can have public inputs and private inputs, and the proof, obviously the public inputs are public, the private inputs aren't. So what you do is you input your private passport data as a private input, and then any information you want to reveal, you set as a public input, and then the program verifies the passport is valid, and then it accepts. So you run all this, and what you get is a proof that you own a legitimate passport, but you don't have to reveal any information about it. Right? It's a zero-knowledge proof. And this allows you to generate very small proofs, like 100 kilobytes or so, which can be verified in about 200 milliseconds. So this is exactly what we need to solve this problem. And when they finally get around to open sourcing their code, those lazy buggers, I'm going to try it out and see if it works. And that's some of the things we've been working on. So thanks very much. Oh, yeah. Thank you.
Thank you, Mike.